Hello everyone, welcome. This is the presentation for the final project of Bangkit Academy presented by the group of JKT-3C. Through this presentation, we will discuss about transfer learning for apple leaf pathology detection. This project is presented by M. Fawaz Maida, me Sabila Hadinisa, and Royhan Mardista. In this presentation, first we will derive about the description of our project, include problem framing, objectives, and metadata. Second will be the explanation of machine learning model, which is the model we apply in this case, include of machine learning, JKT-3C, ResNet, and EfficientNet. Next is the result we get belongs to each machine learning models. In the last section, we'll show the implementation of the model in application and deployment. First is the background. The misdiagnosis of apple tree disease in Indonesia has resulted in continuous losses among farmers. So the photo that we got from comparan.com is news about 420 hectares of apple field in Malang, East Java, threatened with crop failure due to farm that is infected with the disease. But the cause of the disease itself is still difficult to diagnose, and the choice of the wrong drug to treat this disease worsen not only the environment but also increase the cost for farmers. Current disease diagnosis based on human coding are ineffective, time-consuming, and expensive. From this problem came the idea to using machine learning to overcome the apple tree disease detection. So the main problem we'll solve in this project is about how to effectively diagnosing apple tree disease by machine learning. The objective of these cases is to implement machine learning to accurately predict the apple tree disease through the picture of apple leaves. We can implement the machine learning by teaching the pattern of the data. The data set we use in this problem was acquired from Kaggle Research Prediction Competition Plant Pathology 2020. The data attribute is image_ID and 4 binary labels in value of 0 or 1 represent the negative and positive of the 4 conditions that are healthy, multiple disease, RAS, or SCAP. This data consists of 3,642 photos of apple leaves, which is a half of trained data and half of test data. And this is the example of the trained data. So there are 4 labels in the image data, which is healthy, multiple disease, RAS, and SCAP. But just there is one labels that is active or 1 in value. And next is the machine learning models. So in our dataset, it has 4 labels, which is called multi-class classification. So multi-class classification is a classification task with more than 2 classes. For example, is to classify a set of images of fruit which may be orange, apple, or pears, like that. The multi-class classification makes the assumptions that each sample is assigned to one and only one labels. Like in these cases, there are 4 labels, so in this 4 label, just there is one value that is true or in the value of 1, like I said before. In this project, we use transfer learning Because this problem is an image classification, we utilize transfer learning heavily using some available pre-trained model on ImageNet dataset, as most of transfer learning cases from this dataset. And in the image classification flow, we use CNN, which is a deep learning algorithm mostly used for image classification, and it can take an input image, assign importance, learnable weight and biases to various aspects in the image, and be able to differentiate them. So the pre-processing required in CNN is much lower as compared to the classification algorithm. The objective of the convolutional operation is to extract high-level features such as edges, line curve, shadow, and etc. From the image. And convolutional layer is not a part of neural network. It's just a technique to pre-process the image and extract the features information from the image before sending it to the neural network. The original image we gave in input had many unnecessary features and data that we didn't need, but still we had to input them all as a pixel in a matrix. And after convolutional layers, all the noise and unwanted data from the image are removed, and we have a matrix of only dominating features. After going through that process, we have successfully enabled the model to understand the features. And next, we have pooling layers, which is used to reduce the dimension size of the convolved features. And this is done to decrease the computational power required to process the data through dimension reduction. And for the transfer learning, transfer learning is reused to pre-trained model on a new problem. So transfer learning is very popular in deep learning because it can train deep neural networks with comparatively little data. This is very useful since our data just have around 300 of images to train such a complex model. And the benefit of transfer learning is saving training time, better performance of neural network in most cases, and not needing a lot of data.
So just like what have been mentioned before, that we are utilizing transfer learning for this project. So here I will present you some of the all of the model that we use in this transfer learning scenario. The first one is PGG16 or Visual Geometry Group 16. So PG16 is one of the most common used pre-trained image classifier, as this model is simple and powerful. So here I also give a reference to the paper that will discuss the PG16 a lot more. So here is the illustration of how PG16 model accelerator was actually is. So as we can see here, it has a lot of block, consists of convolution, composition, and mask pooling. This block has 5 blocks plus one the last pattern layer, in which every block consists of 3 layers. So hence the name of PG16, as it has 16 layers from the very first convolution till the end of pattern layer. So the deeper counterpart PG19 has also the same apply but has more block, just a 6 block. So in this scenario we are using PGG model as a picture structure, in which we are frozen all the block 1 through 5, and we just train the last part of this, which is a FC classifier, in which we also create this FC classifier to satisfy our task to classify for labels. So the next model that we use is ResNet or residual net. Residual net is one of the prominent pre-trained model available out there. Although this model solves the same problem as PGG did, ResNet basically outperformed PGG-16 on top 1 and top 5 accuracy. This is the paper, Deep Residual Learning for Image Recognition. ResNet introduced us something called residual block. In a simple term, is actually making a shortcut connection from the input, for example the X, to the output layer. That is to combat related problem to dismissing gradient problem. This is one of the illustrations how ResNet is utilized. The third one or the last one is EfficientNet. EfficientNet is a quite recent deep learning paper, as we can see it, is published in 2019 by a group of researchers from Google Brain. This EfficientNet utilizes something so-called compound scaling. EfficientNet also outperforms some of the available models out there, such as ResNet, for example, in which it gained almost the same accuracy with ResNet, but with a lot less parameter number, as we can see here. So this is our training gap for PG16, ResNet, and also EfficientNet. So actually, I don't expect the EfficientNet perform worse than ResNet, but I still expecting ResNet to be better than PGG. So at the end of our training, we try to compare it to the Kaggle leaderboard and submit it to Kaggle. So this is the result. So I mean, this is the method that we use. We are using a categorical cross entropy, confusion matrix, and also AUC or area under the curve. Unfortunately, Kaggle leaderboard only count the AUC for us. So this is the result of the submission. So well, we do expect that ResNet perform better than PGG16 as you can see here in the AUC score, but we don't expect that EfficientNet will be worse than both of them. So after this project, there's something that we learned. So this is what I learned. State-of-the-art model doesn't always guarantee it outperform the simpler model for their particular task. So just give it a try.
Hello, so here my name is Ryan Bardista and I'm gonna explain about the app of this project and the deployment of this project. So in our project we use web application that utilize GitHub pages and then TensorFlow.js, and then we deploy our application in the App Engine, Google App Engine. So our demo app will utilize TensorFlow for the interface, and then the model that we have deployed is taken from the Keras model, and then the file will then be converted into layers of model, and then we can use the engine in Node.js runtime that will be served in pages using the GitHub. Our deployment will only use the PGG model and ResNet model. So there is only two models that we have used in this project. And then here's why the reason why I use TensorFlow.js. Well, because it is efficient net utilize SUS active function, or we can call it a sigmoid function in a certain layers. But the way this SUS activation function implemented is through lambda layer. So here we can see the graphic of the sigmoid function activation. Also, TensorFlow.js layers currently only support Keras models using standard Keras construct. Models using unsupported ops or layers, or we can call it custom layers, lambda layers, and custom classes. or custom metrics cannot be automatically imported because they depend on Python code that cannot be really translated into JavaScript. And here is the link of the demo. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.